Welcome once again. This is teacher Tumsime Tony. So today we are going to take a look at partial fractions, how we split different rational functions given to us into small, manageable partial fractions. I will begin by saying that we know that if we have 1 over x plus 1, say plus 2 over 3x minus 1. If we have this, we can get a combined fraction of these two functions. Obviously, which is going to be, we know that the LCM is that, then x plus 1. So if we get this divided by this, you get this, then multiply this. So you have 3x minus 1, then plus 2 into x plus 1. So we have something like, this is 5x over 3x minus 1, x plus 1. This is 5x, this is minus 1, this is 5x plus 1. So we have got a combined fraction of these two fractions. Then ask yourself a question, that if I am given, 5x plus 1 out of 3x minus 1, then x plus 1, how do we get 1 over x plus 1 plus 2 over 3x plus 1? Now this is 3x minus 1. How do we get this one back? So it is specifically what we are going to talk about. And after having this knowledge is going to help us to solve some integration numbers. We know that this function is very easy to integrate than having this one. So it means that if I'm given to integrate such a number, if I'm given to integrate this number, I will first have to split this into small manageable functions which are easy to do what? To integrate. Specifically, that is the concept. So if I have 5x plus 1 out of 3x minus 1, then x plus 1, I will say this is equal to, a over 3x minus 1, then plus b over x plus 1. So I want to find these constants, a and b, that satisfy this equation here. So I can say 5x plus 1 over 3x minus 1, x plus 1 is equal to a into x plus 1 plus b into 3x minus 1. This is also out of this. You know where this comes from. I just take the LCM of this, then divide it by this, then what I get, I multiply it to an a. This one is okay. So I see here the numerator are equal, so it means that the denominators are equal, which implies that the numerator is also equal. So from here I can say this implies that if I have 5x plus 1 is equal to a into x plus 1 plus b into 3x minus 1. So my job here now is to solve for a and b. How do I solve this? So I can say, I can try to eliminate a. How do I eliminate a? I will say put x equal to -1. If x is -1, so this will be 0. This will go away. So I have -1 times this, then plus. That's why I have -4 is equal to This is negative 1 minus 1 is equal to negative 4b. So my b is equal to a 1. If I want to eliminate my b now, or after getting the b, I can just put x is equal to, how do I eliminate my b? How do I make this thing 0 such that I get a? I'll say if my x is a third, 1 over 3. So I have 5 over 3 plus 1 is equal to, this is a third plus 1, a into a third plus 1, then plus 0. So this one gives me 5 over 3 plus 1, it is 8 over 3 is equal to, this is 4 over 3a. So I'll get my a as 2, such that if I replace my b here and my a here, I still get back that. So that was for purposes of introduction. So let us see. So in case you don't get what I'm talking about clearly, you can replay the video and follow the steps slowly. You can replay that video and follow the steps slowly. So when we are dealing with the partial fractions, we have three types. We have the three types of these partial fractions, and we deal with them differently. The first one is when the denominator is, say, is a product of linear functions, or some people call it linear factors. In some books you find that they talk about them as linear factors. So we know a linear function is the function which takes on the form y equals mx plus c. So you will find that you have a function, e.g., like the one we have done previously. You have, say, 1 over x plus 2, x plus 1. So you're required to split this fraction into different simple fractions or partial fractions. So if the denominator is a product of linear function, we always equate this one to a over 1 of the function plus b over x plus 1, like that. As simple as that. If we had the third one here, we could also add a c and say it is c over another function, like that. So it means these are just constants. You can use your constants. Someone can use m, can use p, can use, so long as after solving those constants satisfy this. You should always check yourself. So maybe let us go through this step. So we have 1 is equal to a into x plus 1 plus b into x plus 2. So if you don't understand where I'm getting this, you just go back in the previous example we have just done. Automatically you shall arrive to this. So from here I can say put my x is equal to negative 1. I want to eliminate this guy here. So now I have 1 is equal to, so this is negative 1 plus 2. So my b is 1. So I say put x is equal to minus 2. Why am I putting minus 2? I want to eliminate this and solve for a. So I have minus 2 plus 1, which is minus 1. So 1 is equal to minus 8. So my a is minus 1 and b is 1, which implies that 1 over x plus 2, x plus 1 is equal to, my a is minus 1. So it is minus 1 over x plus 2, then plus, maybe I got it as 1, so which is 1 over x plus 1. So I have managed to split this fraction into two partial fractions. If you want to go ahead and check whether this satisfies this, you can go ahead and check, and you find that it is satisfying it. So the second type I'm going to talk about is, what about the second one? Sorry. What about if we have, when the denominator is a quadratic function. Is a quadratic functions. We know that some quadratic functions can't be separated. Some quadratic functions can't be separated easily. So, for example, if I have 1 over x squared plus 2x plus 1. So, no. For example, if I have x squared minus 2x, then say plus 1. That. So if I had a fraction like this, how would I split this fraction? First of all, I first check if I can be able to separate this quadratic thing into linear factors. So what does this one give me? It is x minus 1 squared. But we haven't reached to this. This is also a third type that we are going to talk about. Maybe I can try 1 over 6x squared minus 6x, then plus, I can make this a 5. So this reduces to x, say x minus 3, then x minus 2. Hope so. I'm just getting this from the head, but this is x squared minus 3x minus 2x. Then yes, it simplifies to this. So if you have a quadratic function like this, which can be split into that, you can just split it into linear functions, then you apply the other knowledge. But however, sometimes this might not be able to come out. For example, if you had a 7 here, you cannot split this one into linear functions. So what you do, we always handle that this way. Watch. Say e.g. 1 over, I'm going to add a linear function. I'm going to add that one plus 7. If you have a quadratic function down, so this one reduces to a over x plus 1. Then plus, this time around, we shall not say it is b out of x squared minus 5x plus 7. That is not right. So what you are going to do, if it is a quadratic function, we always add bx plus c. We are adding bx plus c. And when we come to applying this one in integration, I'll explain to you why we do this. Because if you get the derivative of this one is a constant. The derivative of this one, if it is a quadratic function, it is a linear function. It helps us so much when you're integrating. So if we have a quadratic function, we always write this like that. And then we do our usual mathematics. For example, this one will become will become 1 is equal to a into x squared minus 5x plus 7, then plus bx plus c into x plus 1, like that. And here we solve for a, b, and c by trying to eliminate very many constants here. For example, you can say put x is equal to -1 such that this one goes away. So I have -1 squared 1 plus 5, 6 plus this. 6 plus 7 is 13. So I have 1 is equal to 13a. So my a is 1 over 13. Don't fear the 1 over 13. So you again put x is equal to 0. If my x is 0, because I want to remove this b, so I will have c plus 7a is equal to 1 plus c. But I know my a is 1 over 13, so I can get c as 1 minus 7 over 13, which is 6 over 13. So I've got the c. How can I get b? Put any other x. Put any other x of your choice and solve for. We have got c and a, and solve for b. Then after solving for b, just come and put those constants there. And after solving that, you can go ahead and check if your answer is right. So that's all we can talk about when the denominator is a quadratic function. That is what we always do. And we shall always come up with a split partial function which is manageable. So the third type and the last one, it is when the denominator has repeated functions or has repeated factors. E.g., what do we mean here? If we have 1 over, say, x minus 2 squared, like that. So you see that the x minus 2 squared is repeated. So we already solve this by equating it to a out of this x plus 1, then plus b out of x minus 2, then plus c out of x minus 2 squared. Like that. If this one was repeated 3 times, we could add a d plus, like in that order. So let's say if this was power 3, this could be squared, then plus d out of x plus minus 2 power 3. Like that. And we simply solve for these constants a, b, and c, d, and they will finally satisfy this. So maybe I can give another example if it is not like that. So if I have, say, x squared minus 2x plus 1, then I have x minus 3, I have x plus 2 squared. You see, whenever you have somewhere like a quadratic function down, first check if this quadratic function can be split into linear factors. So for this, this is a perfect square, so this is x minus 3, then this is x minus 1 squared, x plus 2 squared. So if we split this into fractions, we shall have a out of x minus 3, then plus b, then we deal with this, bx minus 1 plus c x minus 1 squared. Then we also deal with this, so it will be d x plus 2 then plus e x plus 2 squared, which is quite interesting. So you have to solve for 1, 2, 3, 4, 5 unknowns, which is very easy by just playing around with the x's, put x this, put x that, and everything is fine. So that's all we can talk about partial fractions. You can get different numbers from different sources and try them out and try to analyze the denominators, if they are quadratic functions, if they are linear factors, and you come up with, you get used to those fractions. So I'm going to share for more clarifications about, or for more videos, you can reach me out on my email. This is my email. You can just send an email, and why you have sent the email for purposes of education only. Or you can reach me on WhatsApp 753911363. For those who want online lectures, online lessons, you can reach me on WhatsApp or on my email. Okay, see you next time. Bye bye.